In this video, I'd like to chat a bit about LTE interference, or interference from any cellular band for that matter. So what I'm going to do is I'm going to show you how this is measured on my meter, and here I have the Rover HD Tab 700 Plus. Now all I have connected up is just a piece of coaxial cable over there and a small antenna. I've got nothing connected into it, and I certainly haven't connected it up to the LNB or anything along those lines. So I boot up my meter, go to satellite, and I go to spectrum. Now if we look at the spectrum floor, you can see that there's one spike hidden there behind those numbers, but I'm going to focus on this one here. Now periodically you see it's peaking now, and it's peaking at about 45 dB. Now that's a very powerful transmitter. It's sending a signal along this frequency here. You can see there's 11,576 megahertz. Now that frequency it's measuring is not at 11.5 gigahertz. That's what the meter is displaying. So what I need to do is show you how to, first of all, measure the interference, then secondly, work out what the actual signal is so that you know what you're looking at itself. So you can see the spikes, they come and then go, and then every time the cell phone has to send a signal through, it would send a data burst through to the local tower. So pay attention to that. It's at 11,576 megahertz. So let's put our meter aside and let's have a look at some maths. So it's 11,576 megahertz. Now that's a very high frequency, but that's obviously not the frequency that's being displayed. That's the frequency of our satellite transponders. But when that signal is being received by the LNB takes it and puts it through the local oscillator chip inside of there to subtract it, to reduce it so that it works within the IF band. Now the local oscillator for low band, because that's a low band signal, is 9750 megahertz. So if I do the math quickly there, just grab out the calculator, I take my 11,576 megahertz minus 9750 gives me a signal of 1826 megahertz. And that signal is in the IF band. So that's the signal that travels down from the LNB into my decoder. Now remember, a decoder can only see between 950 and 2150 megahertz. So that's smack bang in the middle, that's there. Now 1800 meg is one of the LTE transponders used by the major cellular companies. So if I am connecting up a signal, anything that is on this transponder 11576, both vertical and horizontal, will have a problem, and I'll get a lot more errors on my signal itself. LTE is going to become a big problem for us in the future as satellite technicians, so it's important that we understand how to, number one, measure it, number two, try and alleviate and get around that particular problem itself. So if you need any help trying to figure out or sort out LTE problems, please feel free to get in touch with us. We'll do our best to help you. Have a great day.